Okay, now we're going to take a look at some very special types of integrals, and these are integrals that lead to inverse hyperbolic functions. So we've got 5 types laid out here, and if you look here, we're going to be working in this first example with the du over the square root of a squared plus u squared, which leads to a sinh inverse function. So if I look carefully at what I've got, I should see that it really does fit the form right here. This 9 right here refers to my a, and the x squared refers to my u in this case. So if I think very, very carefully about this, my a in this case is 3, and my u in this case is just a simple x. So we've got to kind of keep that in mind when we work with these types of problems here. Okay, once you've identified that, it actually becomes very easy and very straightforward. All right, now these right here in the table are the cases of the indefinite integrals. We're working with definite integrals because we've got limits of integration. But the hardest part is really identifying which formula to use here and then picking out what it is that you need. So in this case, we've already said that this is the case of the sinh. So we're going to have the sinh inverse, and in this case of u divided by a. Well, u we said earlier was x, and a we said was 3. And the way to figure that out again is by taking the square root of those individual components. And now that we've done that, we can evaluate this using the limits of integration. Okay, so we're going to go ahead and plug in those values here for the value of x. So let's see what we've got. We end up with the sinh inverse of 3 square root of 6 divided by 3 minus, let's see, sinh inverse of the square root of 6 divided by 3. And it looks just like that. So let's see what we end up with here. Well, I notice that my 3's cross out, and I'm left with, in this case, the sinh inverse of the square root of 6 minus the sinh inverse of the square root of 6 divided by 3. And that right there is actually my final answer for this problem here. So really nothing to it. Again, just a matter of picking out the right rule. All right, let's go ahead and take a look at another example. We'll call this one, this last example, number 18. And this is another definite integral. It's going to go from, let's see, from 0 to 4 square root of 3. And it's going to take the form of dx over the square root of 16 plus x squared. So this again, if you look at it, is another case of the sinh. We just have to identify what the u and the a are. In this case, the a is going to be the square root of 16, which is 4, the u being the square root of x squared, which is just x. And now that I've identified that, this makes this really simple because it just follows that form that it evaluates to be the sinh inverse of u divided by a, which in this case is going to be x divided by 4, evaluated from 0 to, let's see, not the natural log, but rather 4 square root of 3. Okay, and so we're going to go ahead and plug that information in. We end up with sinh inverse then of 4 square root of 3 over 4 minus the sinh inverse of, in this case, 0 divided by 4. All right, and this right here is actually going to simplify just a little bit more, and we're going to rewrite this as the sinh inverse. Now the 4's are going to cross out, so sinh inverse of the square root of 3 minus the sinh inverse of 0. All right, so there is another rule that's coming into play here, and these are what we call the relation between the inverse hyperbolic functions and how you can rewrite them, because often calculators don't have these keys. So there is a way to rewrite this. So I'm going to write this off to the side here. All right, and we're going to actually apply this identity. We're going to say that the sinh inverse of x equals the natural log of x plus the square root of x squared plus 1. All right, and it looks just like this. Okay, so we're going to use this identity here, and we're going to apply it to our problem. And so let's go ahead and do that. All right, so in the first case, we're going to take the natural log of basically the square root of 3 plus, and then it's going to be a square root of the square root of 3 quantity square plus 1. Okay, and then we're going to end up with a minus, and then for the next part it's going to be the natural log of the square root of 0. I'm sorry, the square root, yes it is the square root, actually it's not the square root of 0, it's just 0. Okay, 0 plus the square root of 0 square plus 1, and it looks just like that. Okay, and so let's see what this ends up kind of working out to be. All right, when we clean this up, so this square root of 3 squared is 3 plus 1, which is 4, and the square root of 4 being 2. So we end up with the natural log of the square root of 3 plus 2. And way over here on the other side, we end up with a 0 plus the square root of 0 squared plus 1, which is just the square root of 1, which is just 1. So this right here is going to be minus the natural log of 1, but we all know the natural log of 1 is just 0. So our final answer here being that we have the natural log of the square root of 3 plus 2. Okay, so that right there is our final answer for this integral. It really started off looking kind of easy, and then it gradually got a little more difficult, but that's because we needed to know this kind of identity. And again, I'm going to tell you that why do we do this? Okay, so here's the deal. When hyperbolic function keys are not found on a calculator, we can still evaluate the inverse hyperbolic functions by expressing them as logarithms like we did right here. Okay, so there's a trick to this. There's more of these identities involved, but we're only looking at this case of sinh. So be sure that you look up, and maybe in your textbook online, the other logarithmic forms of these hyperbolic functions. So as always, I hope this video was helpful, and remember, like and subscribe.